On the morning of November 24th, 1944, Captain Makoto Sakamoto stood beneath the wing of a massive four-engine bomber that had crashed 3 days earlier near Vladivostok in Soviet territory. The aircraft was unlike anything he had ever seen. It stretched over 99 feet long with a wingspan that exceeded 140 feet. The polished aluminum skin gleamed even under the overcast sky. 4 Wright Cyclone engines, each capable of producing over 2,000 horsepower, hung from the wings like sleeping giants. This was a Boeing B-29 Superfortress, the most advanced bomber in the world, and it was sitting intact on Soviet soil because its crew had made an emergency landing after a raid on the Japanese steel mills in Yawata. Sakamoto was an aircraft engineer with the Imperial Japanese Army Air Service. He had been rushed to this remote location along with a team of 23 other engineers, translators, and intelligence officers. The tone. Soviets, technically neutral in the Pacific War despite their conflict with Germany, had agreed to allow Japanese inspection of the bomber in exchange for diplomatic considerations. What Sakamoto saw in those first few moments would haunt him for the rest of his life. This was not just an airplane. This was proof that Japan had already lost the war. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The B-29 represented a level of industrial capability that Japan simply could not match. Sakamoto walked slowly around the aircraft, his notebook open, his pen moving across the page. He documented dimensions. He examined the skin thickness. He measured the rivet spacing. Every detail told the same story. American manufacturing had achieved something that seemed impossible. The aluminum sheets forming the fuselage were perfectly uniform. No variations in thickness, no imperfections in the surface. The rivets were machine set with precision that Japanese factories could not replicate on such a large scale. The seams were flush, the panels fit together with tolerances measured in thousandths of an inch. Sakamoto had spent his entire career working in Japanese aircraft factories. He knew what Japanese manufacturing could achieve. He had seen the Mitsubishi works. He had visited Nakajima plants. He had inspected aircraft coming off production lines. Japanese engineers were skilled. Japanese workers were dedicated. But Japanese industry was fundamentally different from what he was seeing here. This bomber had been mass-produced. It was one of hundreds rolling off assembly lines in Kansas, Georgia, and Washington state. Everything about its construction assumed unlimited resources, standardized parts, and manufacturing precision that required advanced machine tools. Japan had none of those advantages. He climbed through the forward hatch into the cockpit. The instrument panel stopped him cold. Dozens of gauges, switches, and indicators covered the panel and overhead console. Engine instruments for all 4 engines. Flight instruments with backup systems. Navigation equipment including radio compass and drift meter. Communication systems with multiple frequencies. Radar scope for the bombardier. Everything was labeled in English, but Sakamoto could read enough to understand what he was seeing. Redundancy. Every critical system had a backup. Every engine had independent controls. Every crew position had dedicated instruments. The Japanese aircraft industry focused on simplicity and weight reduction. Pilots flew with minimal instruments. Systems had single points of failure. Redundancy was considered wasteful. It added weight. It complicated manufacturing. But this American philosophy was completely different. They assumed things would break. They designed for failure. They built in backups so the aircraft could survive damage and continue the mission. Sakamoto photographed everything. Other engineers were already measuring, sketching, documenting. One engineer from Nakajima was examining the propellers. Another from Mitsubishi was studying the landing gear. A hydraulics specialist was tracing the lines running through the wings. Everyone was silent. They worked with the intensity of men who understood they were seeing the future, and it did not include Japan. The engines were Wright R3350-23 duplex cyclones, 18 cylinders arranged in 2 rows. Supercharged, fuel injected. Each engine produced 2,200 horsepower at takeoff. The superchargers were driven by exhaust turbines, recovering energy that would otherwise be wasted. Japanese engines used mechanical superchargers that consumed engine power to operate. The American design was more efficient, more powerful, and more reliable. Sakamoto opened one of the cowling panels. The engine installation was extraordinarily clean. Wiring looms were organized and secured with standardized clamps. Fuel lines were stainless steel with proper fittings. Oil lines were similarly professional. Everything was accessible for maintenance. Everything was designed to be serviced quickly. Japanese engine installations were often improvised. Mechanics made do with whatever materials were available. Wire routing was functional but crude. Maintenance required hours of disassembly. This American installation assumed that engines would need frequent service and that mechanics needed easy access. It was designed by people who understood that war was won by logistics as much as by tactics. The bomb bay was cavernous. It could carry 20,000 pounds of bombs. Japanese heavy bombers like the Mitsubishi G4M could carry less than half that amount. The B-29 could deliver that payload at altitudes above 30,000 feet, where Japanese fighters struggled to reach. The pressurized cabin meant the crew could operate in shirt sleeves at those altitudes, while Japanese pilots wore heavy flight suits and oxygen masks. The aircraft had remote-controlled gun turrets, 4 turrets with paired 50 caliber machine guns, 1 turret above the forward fuselage, 1 above the aft fuselage, 2 below the fuselage, plus a tail position with a 20mm cannon. The gunners sat in the pressurized cabin and aimed the turrets using periscope sights linked to analog computers that calculated lead angles automatically. The computers accounted for airspeed, altitude, temperature, and ballistics. The gunner simply put the sight on the target, and the computer adjusted the guns to compensate for all variables. Japanese bombers had manually aimed guns. Gunners sat in open positions, exposed to wind and cold. They aimed by instinct and experience. There were no computers. There was no automation. The difference was not just technological, it was philosophical. Americans built machines to do work that humans did poorly. Japanese doctrine emphasized human skill and dedication, but human skill could not compete with computing machines that never got tired, never got cold, never made mistakes in mathematics. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. Sakamoto spent hours examining the oxygen system. The aircraft carried liquid oxygen stored in insulated tanks. The system could support 11 crew members at high altitude for missions lasting more than 15 hours. The plumbing was complex but logical. Regulators controlled pressure. Flow meters measured consumption. Emergency bottles provided backup. Japanese aircraft used compressed oxygen in heavy steel bottles. The bottles were bulky and held limited supply. Long missions at high altitude were impossible. Japanese bombers operated at medium altitudes where fighters could reach them and anti-aircraft. Fire was effective. The B-29 operated above both threats. It flew higher than most fighters could climb, and higher than most anti-aircraft guns could reach effectively. When Japanese fighters did manage to intercept B-29s, the bombers' speed and defensive armament made attacks extremely costly. The 50 caliber machine guns had range and hitting power that Japanese aircraft could not match. Pilots who pressed attacks were shot down. Pilots who stayed at safe distances could not inflict enough damage. The B-29 was not just a bomber. It was a flying fortress that could defend itself while delivering devastating bomb loads deep into Japanese territory. The navigation equipment included radio direction finders that could track signals from ground stations or from other aircraft. The B-29 could navigate over featureless ocean using radio beacons. It could find its target in darkness or through clouds using radar. Japanese bombers navigated by dead reckoning and visual landmarks. If clouds covered the target, the mission was aborted. If navigation was off by even a few miles, bombs missed their targets. The Americans used technology to remove uncertainty. They navigated by radio. They found targets by radar. They bombed through clouds using radar-aimed bomb releases. Japanese bombers required clear weather and visual confirmation. The Americans could strike regardless of conditions. That meant every day was a potential bombing day. Japanese defenses could never rest. American bombers could attack whenever they chose. Sakamoto examined the radar system located in the nose. The ANAPQ-13 radar could map the ground below, identify cities, rivers, coastlines, and industrial areas through complete cloud cover. The bombardier could identify the target on the radar scope and release bombs using the radar image alone. The system was not perfect, resolution was limited, but it was effective enough to hit large industrial targets, even when visibility was zero. Japan had no comparable technology. Japanese radar was primitive, used primarily for search and early warning, not for bombing. The idea of using radar to aim bombs was beyond Japanese capability in 1944. The technology required miniaturized components, advanced electronics, and precision manufacturing that Japanese industry could not produce in sufficient quantities. Even if Japanese engineers understood the theory, they lacked the industrial base to implement it. The fuel system was another revelation. The B-29 carried over 9,000 gallons of fuel in multiple tanks distributed throughout the wings and fuselage. The tanks were self-sealing, lined with rubber compounds that would swell and close holes when punctured by bullets or shell fragments. Fuel transfer pumps could move fuel between tanks to maintain balance and to feed engines even if some tanks were damaged. Japanese aircraft had unprotected fuel tanks. A single, incendiary round could ignite fuel and destroy the aircraft. Japanese pilots knew that fire was their greatest fear. American pilots flying B-29s knew their tanks could take multiple hits and keep flying. The psychological difference was enormous. American crews could press attacks even under fire because they knew their aircraft could survive damage. Japanese pilots had to break off attacks at the first sign of danger because any hit could be fatal. Sakamoto spent 2 days inside that bomber. He measured, he photographed, he documented, he discussed findings with other engineers. They were all seeing the same thing. The B-29 was not just superior to Japanese bombers. It was superior in ways that could not be quickly overcome. The technological gap was too wide. The industrial gap was even wider. Building one B-29 as an experimental prototype might be possible for Japanese industry. Building hundreds of them was impossible. The United States was producing B-29s at a rate of more than 100 per month by late 1944. Each bomber required more than 500,000 parts. Each part had to be manufactured to precise specifications. The supply chain required thousands of subcontractors producing components that would fit together perfectly when assembled at final factories. Japanese industry was already struggling to maintain production of simpler aircraft. Factories were being bombed. Raw materials were scarce. Skilled workers were being drafted into military service. Production rates were falling. Quality was declining. Aircraft were being delivered with defects that had to be corrected in the field. The idea of ramping up to B-29 level production was fantasy, but the most devastating realization was not about the aircraft itself. It was about what the aircraft represented. The B-29 was not a miracle weapon created by genius engineers working in secret. It was the product of an industrial system, operating at full capacity. It was what American industry could produce when given a design specification and told to manufacture it in quantity. The precision manufacturing, the advanced materials, the electronic systems, the computer-aided gun sights, the radar, the supercharged engines. None of it was magic. It was all the result of industrial processes that American factories had mastered. Processes that required machine tools, quality control, standardized measurements, and trained workers. Japan had never developed those processes. Japanese manufacturing relied on skilled craftsmen building items individually. Parts were hand-fitted. Tolerances were loose. Quality depended on worker skill rather than process control. That approach worked for small-scale production. It could not scale to mass production of complex machines like the B-29. Sakamoto had been an engineer long enough to understand manufacturing economics. He knew that building one perfect machine by hand was impossible. Building 1,000 identical machines required different methods. The Americans had those methods. The B-29 proved it. Every rivet was identical. Every panel was interchangeable. Every component met specifications. That kind of consistency required specialized machinery, statistical process control, and systematic quality assurance. Japan had none of those things at the scale necessary. Even if Japanese engineers could design an aircraft as advanced as the B-29, Japanese factories could not build it in meaningful numbers. The industrial base was insufficient. The machine tools were too few. The skilled labor pool was too small. The supply chain was too fragile. And the war was destroying what little capacity Japan had. American submarines were sinking cargo ships carrying raw materials. American bombers were hitting factories. The flow of aluminum, steel, rubber, and other materials was being cut off. Production was already declining. It would continue to decline. On the evening of the second day, Sakamoto sat with several other engineers in a small room provided by the Soviet authorities. They were drinking tea and discussing what they had seen. The conversation was subdued. One engineer from Mitsubishi said simply that Japan could not build such an aircraft. Another from Nakajima agreed. A third engineer, older, with experience dating back to the 1920s, said something that silenced the room. He said that Japan had lost the war the moment it attacked Pearl Harbor, because Japan had never possessed the industrial capacity to fight America. The B-29 was not the cause of Japan's defeat. It was the proof of Japan's defeat. It demonstrated American industrial superiority so clearly that no one who examined it could deny reality. Japan was being defeated not by better strategy or better tactics, but by better factories. America could build more aircraft, more ships, more tanks, more trucks, more of everything than Japan could ever hope to produce. And American equipment was better, not marginally better, fundamentally better. The B-29 was just one example. American fighters were also superior. The P-51 Mustang had range and performance that exceeded anything Japan could field. The F-6F Hellcat was dominating Japanese fighters in the Pacific. American ships had radar-directed fire control that allowed them to hit targets at night and in bad weather. American submarines were sinking Japanese merchant vessels faster than they could be replaced. The entire industrial output of the United States was focused on winning the war, and that output dwarfed what Japan could produce. Sakamoto returned to Japan in early December 1944. He carried with him thousands of photographs, detailed measurements, technical drawings, and analysis reports. He delivered these materials to the Army Technical Bureau in Tokyo. He briefed senior officers on his findings. He explained the technological advantages the B-29 possessed. He described the manufacturing quality. He discussed the implications for Japanese aircraft production. The officers listened politely. They asked technical questions. They thanked him for his thorough work. Then they filed his reports and did nothing. There was nothing they could do. The information changed nothing. Japan could not suddenly develop the industrial capacity to match American production. Japan could not suddenly train enough skilled workers to manufacture advanced aircraft at scale. Japan could not suddenly create the machine tool industry necessary to support precision manufacturing. The war would continue. Japanese factories would keep building aircraft using methods they had always used. Pilots would keep flying those aircraft against American bombers and fighters. More pilots would die. More cities would burn. The outcome was already determined. The B-29 made that clear to anyone willing to see. The first B-29 raid on Tokyo came on November 24, 1944. The same day Sakamoto stood beneath the captured bomber in Soviet territory. 111 B-29s launched from newly constructed airfields in the Mariana Islands, specifically from Saipan. The distance was over 1,500 miles each way. Japanese commanders had believed such raids were impossible. The Marianas had fallen to American forces only months earlier. Nobody expected operational bomber bases to be constructed so quickly. But American engineers had arrived with prefabricated materials, heavy construction equipment, and thousands of workers. They built runways, taxiways, hardstands, fuel storage, ammunition bunkers, maintenance facilities, and living quarters in a matter of weeks. The speed of construction was itself a demonstration of industrial capability. Japanese forces had occupied islands throughout the Pacific and built modest airfields using manual labor and simple tools. American forces arrived and built massive air bases that could support hundreds of heavy bombers operating continuously. The difference was not just in scale, it was in approach. Americans brought the tools and materials needed to industrialize construction. They used bulldozers, graders, concrete mixers, and cranes. They worked from detailed plans with standardized components. Japanese construction relied on labor gangs with hand tools. The results were predictable. The B-29s that struck Tokyo that November day flew at altitudes above 30,000 feet. Japanese fighters scrambled to intercept, but struggled to reach that altitude. The Nakajima Ki-44 Shoki could climb to 30,000 feet, but it took nearly 20 minutes, and the aircraft's performance degraded significantly at that height. Controls became sluggish. Engine power dropped. The climb rate fell to less than 500 feet per minute. By the time fighters reached bombing altitude, the B-29s had already dropped their loads and were turning for home. Some fighters managed to make attacks. A few B-29s were damaged. One was shot down. But the raid demonstrated what Japanese commanders had feared. High-altitude bombing raids from the Marianas were now routine. Tokyo was within range. So was every other major city in Japan. The home islands were no longer safe. There was no sanctuary. American bombers could appear at any time, drop thousands of tons of explosives, and return to their bases before effective interception was possible. Japanese industry was already struggling before the B-29 raids began. Raw material shortages were severe. Aluminum production had peaked in 1943 at approximately 160,000 tons annually. By 1944, production had dropped to 130,000 tons and was falling further. American submarines were sinking the cargo ships that brought bauxite from the Dutch East Indies. Without bauxite, there was no aluminum. Without aluminum, there were no aircraft. Japanese engineers tried substituting steel for aluminum in some aircraft components. Steel was heavier but more readily available. However, steel airframes were significantly heavier than aluminum equivalents. Performance suffered, range decreased, payload capacity dropped. Aircraft that were already inferior to American designs became even less competitive. Some aircraft factories began using wood for non-structural components. Wheel covers, fairings, and interior panels that had been aluminum were replaced with wood or fabric. It saved small amounts of metal but reflected the desperation of the situation. Japan was regressing technologically while America was advancing. Engine production was another critical bottleneck. Japanese aircraft engines were complex machines requiring precision manufacturing. Cylinder heads, crankshafts, pistons, and connecting rods all needed to be made to tight tolerances. As the war continued, the quality of engine production declined. Skilled machinists were drafted into combat units. Factories hired inexperienced workers to replace them. Training was abbreviated. Quality control was relaxed to maintain production numbers. The result was engines that failed more frequently. Time between overhauls decreased. In 1942, a Nakajima Sakaya engine powering a Zero fighter could operate for hundreds of hours between major maintenance. By 1945, engines were failing after 50 hours or less. Pilots reported rough running, oil leaks, and power loss. Some engines failed catastrophically in flight. Connecting rods broke, cylinder heads cracked, crankshafts fractured. Pilots died not because they were shot down, but because their engines quit. The industrial decline was killing Japanese pilots as effectively as American fighters. Fuel shortages compounded the problem. Japan had gone to war partly to secure access to oil fields in the Dutch East Indies. Those fields had been captured. Oil was being extracted. But getting that oil to Japan required tanker ships, and American submarines were sinking tankers faster than they could be replaced. In 1942, Japan imported over 5 million kiloliters of oil. By 1944, imports had dropped to less than 1 million kiloliters. Refineries in Japan could process crude oil into aviation gasoline, but without crude oil arriving, there was nothing to refine. The fuel shortage affected pilot training most severely. Training flights consumed fuel that was needed for combat operations. As fuel became scarce, training was cut. New pilots received fewer flying hours before being sent to combat units. In 1941, Japanese naval pilots received over 700 hours of training before operational deployment. By 1944, some pilots were deploying with less than 100 hours. They were being sent into combat against American pilots who often had 300 or more hours of training. The experience gap was enormous. American pilots had trained extensively in aircraft similar to what they would fly in combat. They had practiced gunnery, navigation, formation flying, and tactics. Japanese pilots in 1944 were being rushed through abbreviated programs that covered only basic flight skills. They reached operational units without adequate preparation. Many died in their first combat missions. The strategic situation was deteriorating everywhere. In the Philippines, American forces had landed on Leyte in October 1944. Japanese naval forces had attempted to stop the invasion with a complex operation involving 3 separate fleets. The Battle of Leyte Gulf resulted in catastrophic losses for Japan. 4 aircraft carriers sunk, 3 battleships sunk, multiple cruisers and destroyers lost. The Japanese Navy ceased to exist as an effective fighting force after Leyte Gulf. The ships that survived lacked fuel to operate. They remained in port, immobilized, while American naval forces roamed freely throughout the Pacific. The loss of the Philippines cut Japan off from the Dutch East Indies. Oil shipments stopped almost completely. Rubber, tin, and other critical materials from Southeast Asia could no longer reach Japan. The economic strangulation was nearly complete. Japanese factories were running out of raw materials. Production was falling. The military was consuming equipment faster than industry could replace it. The mathematics of attrition were simple and brutal. Japan was losing aircraft, ships, and trained personnel at rates that could not be sustained. America was building new aircraft and training new pilots faster than Japan could destroy them. The gap was widening every month. Japanese commanders understood the situation but had no solution. Surrendering was politically impossible. The military government that had led Japan into war could not admit defeat without risking revolution. The emperor's position was tied to military success. Defeat meant potential overthrow of the entire system, so the war continued even though the outcome was inevitable. Orders were issued to fight harder, to show more spirit, to embody Yamato Damashi, the spirit of Japan. Pilots were told that fighting spirit could overcome material disadvantage. If they believed strongly enough, if they were brave enough, if they were willing to die, they could still win. It was a comforting lie that sent young men to their deaths. Fighting spirit could not overcome radar-directed gunfire. Bravery could not compensate for inferior aircraft. Willingness to die did not defeat B-29s flying at 30,000 feet. In early 1945, Japanese commanders began implementing Tokko tactics, special attack tactics, commonly known in the West as kamikaze attacks. If conventional attacks could not stop American ships, then pilots would deliberately crash their aircraft into enemy vessels. The logic was coldly practical. A pilot who crashed his aircraft into a ship guaranteed at least one hit. Conventional bombing and torpedo attacks had very low success rates. Pilots expended aircraft and bombs without hitting anything, but a deliberate crash meant the aircraft itself became the weapon. The pilot, the aircraft, and whatever explosives it carried would all impact the target. Japanese commanders calculated that kamikaze attacks achieved hit rates around 14%, far higher than conventional attack success rates of less than 1%. The mathematics suggested that sacrificing pilots in suicide attacks was more efficient than sending them on conventional missions, where they would likely be shot down anyway without hitting anything. The decision reflected absolute desperation. Nations with hope for victory do not systematically sacrifice their trained pilots. Japan was doing so because there was no other option that seemed to offer any chance of inflicting meaningful damage on American forces. The first organized kamikaze attacks occurred during the Battle of Leyte Gulf in October 1944. Vice Admiral Takejiro Onishi organized a unit of volunteer pilots on Luzon in the Philippines. 26 pilots volunteered for the first missions. On October 25th, they attacked American escort carriers of Task Unit 77.4.3, known as Taffy 3. 5 kamikazes hit American ships. The escort carrier USS Street, Low, was sunk. Several other ships were damaged. From the Japanese perspective, the attacks were successful. 5 obsolete fighters flown by inexperienced pilots had sunk one carrier and damaged others. Conventional attacks would have required far more aircraft and likely would have achieved less. Onishi expanded the program. More pilots volunteered or were assigned. Kamikaze units were organized throughout remaining Japanese-held territories. By early 1945, Tokko attacks had become standard doctrine. Hundreds of aircraft were being expended in suicide attacks. Thousands of pilots were dying. The program consumed Japan's remaining air power in a desperate attempt to stop the American advance. The human cost was staggering. Kamikaze pilots were mostly young men in their late teens or early 20s. Many were university students who had been drafted and given minimal flight training. They knew they were going to die. There was no pretense otherwise. Mission briefings were farewells. Pilots wrote final letters to families. They drank sake toasts. They received ceremonial headbands. Then they took off, knowing they would not return. Some pilots were genuine volunteers, motivated by patriotic fervor. Others were effectively coerced. In the military culture of wartime Japan, refusing a suicide mission was unthinkable. It meant dishonor not just for the individual, but for his entire family. Social pressure ensured compliance. Young men who might have preferred to live went to their deaths because refusing was worse than dying. The spiritual justification was that death in service to the emperor guaranteed honor and eternal glory. Pilots were told they would be enshrined at Yasukuni Shrine, where their spirits would be honored forever. They were told their sacrifice would save Japan. They were told their deaths had meaning. For many pilots, those assurances were enough. They found purpose in their final missions. Others went to their deaths in quiet despair, trapped by circumstance, unable to refuse, unable to escape. American sailors faced kamikaze attacks with growing dread. Conventional air attacks could be defended against with fighter patrols and anti-aircraft fire, but kamikaze attacks continued even when the aircraft was badly damaged. Pilots who were wounded kept coming. Aircraft that were on fire kept coming. As long as the aircraft could still fly, it remained a threat. Anti-aircraft gunners learned to keep firing until the attacking aircraft was completely destroyed. Even then, flaming wreckage would sometimes hit the ship. The psychological impact was severe. American sailors knew that every Japanese aircraft might be a kamikaze. Every contact on radar might be the beginning of an attack. The constant threat wore on crews. Some ships were hit multiple times and survived. The aircraft carrier USS Franklin was hit by 2 bombs on March 19, 1945, and nearly sank. Over 800 crew members died. Other ships were hit by kamikazes and damaged but remained operational. A few were sunk. The attacks were effective enough to justify continued use from the Japanese perspective, but not effective enough to stop American operations. Meanwhile, B-29 raids on Japan intensified. In January 1945, Brigadier General Haywood Hansell was replaced as commander of the 21st Bomber Command by Major General Curtis LeMay. LeMay had commanded bombing operations in Europe and understood strategic bombing better than almost anyone in the military. He looked at the results of high-altitude precision bombing raids on Japan and was unsatisfied. The raids were hitting targets but not destroying them completely. Japanese industrial facilities were dispersed. Factories were small and numerous rather than large and concentrated. High-altitude bombing with individual aircraft aiming at specific buildings was inefficient. LeMay made a radical decision. He ordered low-altitude night incendiary raids on Japanese cities. Instead of bombing from 30,000 feet in daylight, B-29s would attack from 5,000 feet at night, carrying incendiary bombs designed to start fires. Japanese cities were uniquely vulnerable to fire. Most buildings were wood construction. Streets were narrow. Fire prevention infrastructure was minimal. A concentrated incendiary attack could create firestorms that would consume entire neighborhoods. The first major incendiary raid hit Tokyo on the night of March 9th to 10th, 1945. 334 B-29s attacked in waves. They dropped over 1,500 tons of incendiaries on a densely populated area of eastern Tokyo. The bombs created hundreds of individual fires that quickly merged into a firestorm. Winds reached hurricane force as the fire consumed oxygen. Temperatures exceeded 1,800 degrees Fahrenheit. People caught in the firestorm died from heat, smoke inhalation, or asphyxiation as the fire consumed all available oxygen. The official death toll was over 88,000, but the actual number was likely higher. More than 1 million people were left homeless. 16 square miles of Tokyo burned. The destruction exceeded anything yet seen in the war. It was worse than the atomic bombings that would come later in terms of immediate casualties. LeMay had found the method that would break Japan's ability to wage war. Not by destroying factories directly, but by destroying the cities where workers lived, making industrial production impossible. Incendiary raids continued throughout March, April, and May. Nagoya, Osaka, Kobe, and dozens of smaller cities were burned. Japanese air defenses were increasingly ineffective. Fighter units lacked fuel, experienced pilots, and serviceable aircraft. Anti-aircraft ammunition was in short supply. Guns were worn out from constant use. The B-29s attacked with near impunity. By June 1945, most major Japanese cities had been substantially destroyed by fire. Industrial production had collapsed. What factories remained intact could not operate because workers were dead, displaced, or occupied with survival. The transportation system was breaking down. Trains could not run because tracks were damaged and repair materials were unavailable. Trucks could not operate because fuel was unavailable. Food shipments from rural areas to cities were disrupted. Urban populations faced starvation. The Japanese government implemented strict rationing but could not prevent widespread hunger. People survived on diminishing rations of rice supplemented with whatever could be foraged. Malnutrition became epidemic. Children showed signs of stunted growth. Adults lost weight and strength. Disease spread as sanitation systems failed and medical care became unavailable. Japanese military planners knew invasion was coming. American forces had taken Iwo Jima in March and Okinawa in June after brutal fighting. The next step was obvious. American forces would invade the home islands. Japanese commanders prepared for Ketsugo, the decisive battle for Japan. Every available soldier, sailor, and airman would fight. Civilians would fight. The entire population would resist. Schools trained students in combat. Women practiced with bamboo spears. The plan was to make invasion so costly that America would negotiate peace, rather than continue. It was fantasy. America had no intention of negotiating. The plan was complete conquest and unconditional surrender. Japanese resistance would be crushed regardless of cost. American military planners estimated casualties for the invasion of Japan would be extremely high, but they were prepared to accept those losses to end the war. The alternative was continuing the bombing and blockade until Japan collapsed, which might take years. Invasion would force a resolution within months, but technology intervened. On July 16, 1945, the United States successfully tested an atomic bomb in New Mexico. The explosion released energy equivalent to 20,000 tons of TNT. The blast created a crater and vaporized the steel tower supporting the device. Scientists confirmed that the weapon worked. 2 operational bombs were available. The decision was made to use them against Japan to force immediate surrender and avoid invasion. On August 6th, a B-29 named Enola Gay dropped the first atomic bomb on Hiroshima. The city was destroyed instantly. Over 70,000 people died immediately. Tens of thousands more would die from radiation effects. 3 days later, another atomic bomb destroyed Nagasaki. The emperor intervened personally and ordered acceptance of surrender terms. On August 15th, 1945, Emperor Hirohito announced Japan's surrender in a radio broadcast. His voice was thin and formal, speaking in court Japanese that many ordinary citizens struggled to understand. But the meaning was clear. The war was over. Japan had lost. Captain Makoto Sakamoto learned of the surrender while working at a requisitioned factory building in the outskirts of Tokyo. The building had survived the firestorms by luck of location. He and several other engineers had been analyzing salvaged American equipment, trying to extract any useful intelligence even as the war crumbled around them. When the announcement came over the radio, the room fell silent. Some men wept, others sat motionless, faces blank. Sakamoto felt nothing at first, then a strange sense of relief. The pretense was over. Everyone could stop pretending that Japan had any chance of victory. The war he had known was lost the moment he examined that B-29 11 months earlier was finally, officially ended. He thought about all the young pilots who had died in those 11 months. Thousands of them. Boys barely old enough to shave, sent up in obsolete aircraft to face American fighters and bombers they had no realistic chance of defeating. They had died believing their sacrifice mattered. They had died believing fighting spirit could overcome material disadvantage. They had been lied to by commanders who knew better but sent them to die anyway because there was no alternative that preserved honor. Sakamoto had known the truth. He had documented it. He had reported it. And nothing had changed because the truth was too painful to accept. In the weeks following surrender, American occupation forces arrived in Japan. They came with trucks, jeeps, supplies, and an attitude of overwhelming confidence. Japanese civilians watched in silence as American convoys rolled through ruined cities. The contrast was striking. Americans were well-fed, well-equipped, and casual in their dominance. Japanese survivors were hungry, ragged, and defeated. But the occupation was not brutal. American forces distributed food. They established order. They began reconstruction. For many Japanese civilians, the arrival of Americans meant survival. Food shipments from America prevented mass starvation. Medical supplies treated diseases that had been spreading unchecked. The occupation was pragmatic rather than vengeful. American authorities wanted a stable Japan that would not threaten future peace. That required rebuilding rather than punishing. War crimes trials would address specific atrocities, but the general population would be helped to recover. It was a remarkably enlightened approach that reflected American strategic thinking. A destroyed Japan would be a breeding ground for extremism and future conflict. A rebuilt Japan could become a stable ally in the Pacific. The investment in reconstruction was calculated to serve American interests, but it also served humanitarian goals. Sakamoto was interviewed by American technical intelligence officers in September 1945. They wanted to know about Japanese aircraft development, manufacturing capabilities, and technical assessments. He answered honestly. He described the industrial limitations Japan had faced. He explained the resource shortages, the decline in manufacturing quality, the impossibility of matching American production. The American officers listened carefully and took extensive notes. One officer asked specifically about the B-29 examination in Soviet territory. Sakamoto confirmed that he had examined the aircraft, prepared detailed reports. The officer asked what conclusions Sakamoto had reached. Sakamoto replied that the B-29 represented industrial capability that Japan could never match. The officer nodded and said that assessment was correct. Then he asked a different question. He asked whether Japanese military leadership had understood that Japan could not win an extended war against American industrial power. Sakamoto paused before answering. He said that some leaders understood but could not act on that understanding because doing so would mean accepting defeat before the war began. The officer wrote that down without comment. The interview continued for several hours. At the end, the American officer thanked Sakamoto for his honesty and said his technical knowledge would be valuable during reconstruction. Japan would need engineers who understood modern manufacturing methods. American advisors would help rebuild Japanese industry using better techniques. Sakamoto would have opportunities to work on that reconstruction if he was interested. Sakamoto said he was very interested. Japanese aircraft factories were dismantled under occupation authority orders. The facilities at Mitsubishi, Nakajima, Kawasaki, and other companies were stripped of equipment. Machine tools were catalogued. Some were shipped to other countries as reparations. Some were destroyed. The factories themselves were repurposed for civilian production. Mitsubishi began producing bicycles, sewing machines, and kitchen equipment. Nakajima became Fuji Heavy Industries and eventually developed automobiles. The engineers who had designed fighters and bombers now worked on civilian products. The transition was difficult. Military engineering required different priorities than civilian engineering. Military designs emphasized performance over cost. Civilian designs required the opposite. Products had to be affordable, reliable, and manufacturable at scale. Japanese engineers had to learn new methods. American advisors taught statistical process control, standardized measurements, and quality assurance techniques. These were the methods that had allowed American factories to mass-produce aircraft like the B-29. Now they were being applied to civilian manufacturing in Japan. The results would not be immediate, but over decades, Japanese industry would transform into one of the most efficient manufacturing systems in the world. The lessons learned during occupation would become the foundation of Japan's post-war economic miracle. The human cost of the war remained visible everywhere. Cities were ruins, millions were homeless, orphans begged in the streets, veterans returned from overseas, many missing limbs, all traumatized. The psychological damage was as severe as the physical destruction. An entire generation had grown up in militaristic culture that emphasized sacrifice and obedience. That culture had led them into a war that killed millions and destroyed their country. Now they had to build something different. The process would take decades. Some veterans never recovered. They carried guilt, anger, and trauma for the rest of their lives. Some felt betrayed by leaders who had sent them to fight an unwinnable war. Others clung to military values and never fully accepted defeat, but most simply tried to survive and rebuild. They found work, they married, they raised children. They tried to create normal lives in the ruins of their country. The generation that fought the war did not talk about it much. The memories were too painful. The shame of defeat was too heavy. They focused on the future instead of dwelling on the past. Children born in the immediate post-war years grew up in poverty, but also in peace. They knew hunger and hardship, but not war. Their parents and teachers emphasized education and hard work. Japan would rebuild through knowledge and effort. Students studied intensely. Schools were crowded and under-resourced, but attendance was near universal. Education became the path to opportunity. Students who excelled could attend universities and pursue careers in the rebuilding nation. The emphasis on education would create a highly skilled workforce that drove economic growth in the 1950s and 60s. But in the immediate post-war period, the future was uncertain. Survival was the primary concern. Food, shelter, and basic security were difficult to obtain. Black markets flourished. Crime was common. The social order had collapsed and was slowly being rebuilt under occupation authority. American military police maintained order in major cities, but rural areas were often lawless. Displaced persons wandered the countryside looking for food and shelter. Refugees from former colonies returned to Japan and found a country unable to support them. Ethnic Koreans and Chinese who had been brought to Japan as forced laborers during the war were stranded without resources or legal status. The occupation authorities eventually arranged repatriation for many, but the process was slow and chaotic. The psychological impact of the atomic bombings was particularly severe. Hibakusha, the survivors of Hiroshima and Nagasaki, faced not only physical injuries and radiation sickness, but also social stigma. Many Japanese believed that radiation exposure was contagious or hereditary. Hibakusha had difficulty finding employment or marriage partners. They were treated as contaminated, dangerous, cursed. The discrimination persisted for decades. Children of Hibakusha faced similar prejudice even if they had not been exposed to radiation themselves. The atomic bombings became a defining trauma in Japanese national consciousness. They were remembered as uniquely horrific weapons that should never be used again. The bombings were cited as proof of the inhumanity of modern warfare. But there was also complex guilt among some Japanese observers who recognized that Japan's own conduct during the war had been brutal and that the atomic bombings were partly a consequence of Japan's refusal to surrender despite obvious military defeat. That recognition was uncomfortable and often suppressed in public discourse, but it existed in private reflections. Sakamoto continued working as an engineer through the occupation period and into the 1950s. He helped rebuild manufacturing facilities and train younger engineers in modern methods. He saw Japanese industry transform from the crude, hand-fitted production methods of the war years to sophisticated mass production systems that rivaled anything in the world. By the 1960s, Japan was producing high-quality automobiles, electronics, and machinery for export. The country that had been devastated in 1945 was becoming an economic power. Sakamoto lived long enough to see that transformation. He retired in 1972 at the age of 63. In retirement, he occasionally gave lectures at technical universities about aircraft engineering and manufacturing history. He never spoke publicly about his examination of the B-29 until the 1980s, when a historian researching wartime intelligence operations contacted him. The historian was documenting Japanese technical assessments of American equipment. Sakamoto agreed to an interview. He was in his 70s by then, long retired, and felt free to speak honestly about matters that had been classified or sensitive decades earlier. During that interview, Sakamoto described in detail what he had seen when examining the B-29. He talked about the manufacturing quality, the advanced systems, the industrial capability it represented. The historian asked whether Sakamoto had realized at the time that Japan could not win the war. Sakamoto said yes, he had realized it immediately. The B-29 was proof that American industrial capacity was overwhelming. Japan simply could not compete. The historian asked why Japanese military leadership continued the war for nearly another year after that assessment. Sakamoto was quiet for a long moment before answering. He said that military leaders were trapped by their own ideology. They had built a system that made surrender impossible. Admitting defeat meant admitting that the entire war had been a mistake. It meant accepting personal responsibility for millions of deaths. It meant dishonor so profound that suicide was preferable. So, they continued the war, even though they knew it was lost. They sent young men to die, even though they knew those deaths would not change the outcome. They ordered kamikaze attacks, defended cities that could not be held, and prepared for invasions that would only increase casualties. They did this because stopping meant facing truths they could not accept. The historian asked if Sakamoto felt anger toward those leaders. Sakamoto said he had felt anger at the time. Now he mostly felt sadness. The leaders had been trapped by a system they helped create. They were victims of their own ideology. That did not excuse their decisions, but it explained them. The interview was published as part of a larger historical study in 1987. It received little attention in Japan, where discussion of wartime decisions remained sensitive, but historians studying the Pacific War found it valuable. Sakamoto's account provided insight into how Japanese technical experts understood the industrial gap between Japan and America. It confirmed that knowledgeable observers within Japan recognized the impossibility of victory relatively early in the war, but could not influence policy. The system did not allow for honest assessment if that assessment contradicted official narratives. Engineers and analysts could document reality, but could not force leaders to act on that reality. The disconnect between technical understanding and strategic decision-making contributed to Japan's catastrophic defeat. Leaders made decisions based on ideology and honor rather than realistic appraisal of capabilities. The result was predictable. Japan fought until it was utterly destroyed because the alternative was unthinkable to those in power. Sakamoto died in 1994 at the age of 85. His obituary in the Technical Journal, where he had published papers throughout his career, mentioned his contributions to post-war industrial development, but said little about his wartime service. That was typical. The generation that fought the war did not seek recognition for wartime activities. Many actively avoided discussing that period. The war was a source of shame, not pride. Japan had been the aggressor. Japan had committed atrocities. Japan had lost completely. There was nothing to celebrate. The post-war generation preferred to focus on reconstruction and economic success. Those achievements were worth commemorating. The wartime period was best left unexamined. That attitude persisted for decades and only began to change slowly in the late 20th century, as younger historians started studying the war with more objectivity and less emotional connection to the events. The B-29 that Sakamoto examined in Soviet territory had its own fate. After Japanese inspection was complete, Soviet engineers conducted their own analysis. Stalin had ordered the development of a Soviet strategic bomber and saw the B-29 as a model to copy. Soviet engineers reverse-engineered the aircraft completely. They measured every part, documented every system, and created manufacturing drawings for Soviet factories. The result was the Tupolev Tu-4, a nearly exact copy of the B-29. The Soviets built over 800 Tu-4s between 1947 and 1952. The aircraft served as the Soviet Union's primary strategic bomber through the early Cold War. It gave the Soviets the capability to deliver nuclear weapons to distant targets. The fact that Soviet strategic bombing capability was based on a copied American design was ironic but practical. The Soviets had no equivalent aircraft and needed one urgently as tensions with the West increased. Copying the B-29 was faster than developing an original design. The 3 B-29s that had landed in Soviet territory during the war, including the one Sakamoto examined, provided the template. Soviet engineers did what Japanese engineers could not. They not only understood the advanced technology, but possessed the industrial capability to replicate it at scale. The story of that captured B-29 and Sakamoto's examination of it illustrates a fundamental truth about warfare in the industrial age. Victory is not determined primarily by courage, tactics, or fighting spirit. Victory is determined by industrial capacity. The side that can produce more equipment, train more personnel, and sustain operations longer will prevail, regardless of tactical brilliance or individual heroism. Japan entered the war with experienced pilots, effective tactics, and aircraft that were superior in some respects to early American designs. But Japan lacked the industrial base to sustain a long war. American industry could absorb losses and increase production. Japanese industry could not. Every aircraft Japan lost was difficult to replace. Every experienced pilot killed was nearly impossible to replace. America lost far more aircraft and pilots in absolute numbers, but replaced them faster than they were lost. The force grew stronger over time. Japan's force grew weaker. The mathematics were inexorable. By 1944, the disparity was so great that Japanese defeat was certain. The B-29 was simply the most visible symbol of that disparity. It represented everything Japan lacked: advanced technology, precision manufacturing, abundant resources, and the industrial infrastructure to produce complex machines at scale. Japanese engineers who examined it understood immediately what it meant. Japan had already lost. The lessons from that realization extend beyond World War II. Industrial capacity remains fundamental to military power. Nations with advanced manufacturing, robust supply chains, and technological sophistication possess inherent advantages in sustained conflict. Tactics and training matter, but they cannot compensate for overwhelming material disadvantage. The Japanese pilots who died fighting B-29s were brave and skilled, but their bravery and skill were insufficient. They were fighting an enemy who could replace losses faster than they could inflict them. The same dynamic has appeared in every major conflict since. The side with greater industrial capacity and resource access almost always prevails in extended wars. Short conflicts may be determined by other factors, but long wars are won in factories. That was true in World War II. It remains true today. Technology has changed. Manufacturing methods have advanced. But the fundamental principle endures. Industrial power translates to military power. Nations that understand this invest in manufacturing capability, supply chain resilience, and technological development. Those investments determine who wins wars decades later. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.